Good day. This is a guide for plant engineers, specifically who do selection of medium voltage cable selection. Most of the engineers in a plant, I think today, do not really know how to do accurate selection of cables for the plant. Okay, let's go to the next one. Selection of medium volt cables. How to select a cable. What's important, the size of the load. We must know the volt drop, calculate the volt drop. Prospective volt drop, this circuit protection, and the condition of installation. Now, the first point we're going to look into is the load that must be supplied. Now, if we want to work out the full load, the I full load, then we need to use this formula here, I full load, to work out the amps or kiloamps of the specific circuit. That's very important to know that. Second one is, what's also important, is example of a low voltage selection. We take a 400 volt, three-phase. It's the power is a motor, 100 kilowatt motor, star delta starter with the distance of the cable is 50 meters. Power factor is a 0.9, lagging. So now you can see that using that I full load amperage full load calculation, and we come to 161 amps. Then we can refer to the table. A 52 square can carry 169 amps. Let's go check it. 50 square. That is that one, and we can see 163 amps. Cables carrying, so it's very handy to use. This is a lot of information on this table that's going to be used. The impedance, we can do the three-phase, single-phase volt drop can also be done. And then we go to permissive volt drop calculation. The first thing we need to know is the permissive volt drop. So what we do, there's two methods. We can use the method one. We take it as starting current, use it 3 times the running current because it's star delta. You can be specified different from the manufacturer, but for this example, we use 3 times running current. And that gives us 483 amps. And then the impedance for 50 meters, 50 square. If you go to table 1, you'll see it's 0.478 is the reading, divided by 1,000 times 50. That's a formula that gives you 0.02359 ohms. That is the impedance. And then we work out the volt drop. We use the full load amps times impedance of the cable. That gives me the volt drop. Then the percentage volt drop is 4.95, acceptable, because we know that IEC standard is about 5, that's plus minus 5% that we will work on, especially for medium voltage cables. Let's go to the next one. Method 2, starting current. Again, 3 times 166, that gives me 483 amps. Volt drop, ampere meter. That is what we get from the table. And then the formula is times the amps times the meters. I come to 19.73 volts, 4.93. That gives me the volt drop. So that cable is in line with the volt drop. Then selection, medium voltage cable. That is for a normal under 1,000 volt cable. Now we come to above 1,000 volt, 11 kV, 2 MVA transformer, distance is 3 kilometers. We're going to use this formula to calculate the amps. We get the amperage. And then also we know we have a derating factor in the depth of the burial is 1.9. So that is the first one. That's the second derating factor. That we 0.84 and 1.00. The third derating factor. Then we get a total derating factor is that value times that you take the first one times the second one. So it's 1, 2, and the third one. We come to this value. Then equivalent standard current rating is divide the full load amps, and then we get 180 amps. That we know is the carrying capacity of that cable. Cable 2, we go here, we will see that the 50 amps is base amperage. 160, that's 150 square is 160 amps. 160 amps. Okay, now we go here. From the table, if we go back to that table, we see the closest there is a 35 square. The 3-core cable carrying the following load, vol drop. So we can calculate the vol drop. This is a formula that you use to calculate the vol drop. That is impedance, square root 3 times I times distance divided by 1,000. We come to the value and see the vol drop is very good. Vol drop is no problem, even for long runs. Most of the cables you'll select, most of the vol drops is good. Short circuit level, we assume at 250 fault level, and then for 600 perspective, symmetrical short circuit current, 250 divided by square root 3 times the voltage, is 11,000 volts. That gives me the I short circuit. This is gives you the I short circuit. I short circuit. Now, cable short circuit withstand. This is very important. The word short circuit withstand for half a second. Cross sectional K value. This K value. That's all you get from the manufacturer. The other two from table and your time, what you can use. Now we see that the K value is 115 amps per square millimeter of copper conductor, paper insulated. This is the cable that we're using. So it's a 35 times 115 divided by 0.5 because it's for a half second. And we will see that the percent carrying capacity is 5.692 kiloamps. 2 kiloamps. Previous, as you go back to the table, you will see that the cable is too small to carry that capacity, fault capacity. So the conductor size, therefore, is to work out the correct conductor size. You use X times 115 divided by square root 0.5. That gives you the that is the kiloamps, and this will gives us that X is 80 square. Now, K value for the manufacturer, the best cable that we can go is you can work on the table. You'll see the best cable according to the table is a 95 square cable, 235 amps. Now let's see the earth fault for half a second. And then we go to, they say that the diameter is 200 millimeters, so we can use 200. The K value from the manufacturer is 24, and then divided by square root 0.5. So that gives us 6.8 kiloamp half second. And the quote asphalt that we going to use, calculate, we use this formula, and you will come to 5.25 kiloamp per half second. And that will give us a conclusion if you compare it all with the tables that is required on the table for the specific. So the main factor, this is very important. The main factor goes on is by the prospective short circuit current. So once you've checked that you can carry the load, the amperage, the volt drop is correct, and then the third one, prospective short circuit current for a half a second, that it is according to the spec on the cable, then you will be safe. You choose the correct and a safe cable for a safe installation. In my experience, I've seen most of the engineers really don't know how to select the cable. They just go for the length of the cable, see that they can carry the amperage, never calculate the I short circuit, and also the prospective short circuit for the cable for a half a second. That's never been calculated compared to the tables to get the correct square millimeter of the cable. This is a safe way to do it. Please, if you like the video, press the like button. Please subscribe. This is my first training video. It will get better in the future, but please subscribe, give me comments, and God bless. Bye-bye.